In this chapter, we will be learning to write the equations of lines given various pieces of information. In the last chapter, we started with the equations of lines. We were able to graph the lines, find ordered pairs that satisfied them, and we used slope-intercept form a lot. In slope-intercept form, y equal mx plus b, remember, is when y is alone. It's also called function form, and when that's the case, the coefficient of x is the slope, and the constant is the y-intercept. So if we're given the slope and the y-intercept, then we can immediately just write the equation of the line. In this case, since the slope is negative 2/3, we'll write negative 2/3 x, slope's the coefficient of x, plus the y-intercept, in this case a half, and there's the equation of the line. If we wanted to graph it, we'd plot the 1/2, we'd go a half a block up from the origin, and then down 2 full blocks and write 3. So if we're given a graph, we can also determine the equation of the line by looking, as long as we can read the y-intercept from the graph. In this case, that's pretty easy to do. So we know we're going to have y equal our slope times x plus the y-intercept in this case, which is negative 4. Now if we want to count blocks for the slope, since we have the graph, we see if we go up 2 blocks and write 1, we get another integral value. I'm just going to check it, up 2, write 1, yep, and there's a point that they plotted for us. So the slope is 2 over 1, which is equivalent to 2. Now I certainly could have said up 4, write 2, and that would still be equivalent to a 2. So while we're graphing, just a reminder, we also took equations in standard form, like 2x plus 3y is equal to 6, and we graphed our line by doing the intercepts. So if we let x be 0, that term drops out, and we get 3y is 6 or y is 2. If we let y be 0, we get x is 3. So we can plot the point 0, 2, point 3, 0, and we'd have that line graphed easily. Now in this chapter we're going to start with linear relationships, word problems, and we're going to just try to see that line in there. And the thing that makes a line, a linear relationship in a word problem, is that you hear some constant rate of change. And that constant rate of change is the slope of the line. Usually there's also some initial value, sometimes like a time 0 or something like that, and that will be the y-intercept. Take a look at a relationship. Here's some population data in California. It says in 1990, California had a population of 29.76 million. During the next 15 years, the state's population was expected to increase by an average of about 0.31 million people per year. So that increase of about 0.31 million people per year, there's that constant rate of change. So looking at that, if we think in terms of, well, let's let the population be a function of the number of years since 1990, since that's kind of our reference point. So that's our beginning value, and then it's going to increase by 0.31, so there's the constant rate of change, which represents the slope. So 0.31 times, I'll use t for the number of time, the years since 1990, and then the initial value in 1990 is 29.76. And again, this is in millions, so millions of people. So there's our formula for that relationship from 1990 and just the next 15 years, because that's all the data tells us. So how many people were in 2005? Well, 2005 from 1990, if my arithmetic's right, it's 15 years. You can check me on that. So we want to put a 15 in for t and just compute that. So there's our equation for population, just reordered here. So 29.76 million plus 0.31 times 15. So we get 4.65 added on, so we get about 34.41 million people in 2005. So I've graphed that. You can see the initial value, again, in 1990, so when time is 0, 1990, the 29.76, there's the y-intercept, and then we have the 0.31 million people is the slope. You can see the graph. So here's another linear model, telephone rate. So you might get a bill that looks something like this. And if you look at the bill, and you can see for each of those dates, the first minute is 3.44. It's a fixed cost. And then there's a rate for each additional minute, which appears to be 24 cents for each additional minute. So again, that's a linear relationship because of that constant rate of change. So if we think about what's the cost would be for the bill, the cost would be, well, that initial value of $3.44, that becomes the y-intercept. So even if you just don't even talk, or when you first start talking, you get charged that $3.44 even before a minute has elapsed. And then you're going to get a charge of 24 cents for every additional minute. I'll use M for minute. So in part B there it says, how much would a 9-minute collect call cost? Well, 9 minutes would be the first minute, there's your 344, and then 8 additional minutes. And there you have it, 344 plus the 24 cents times the 8 additional minutes would cost $5.36. Notice the graph. So now if we want to write a linear equation to model this situation, your uncle weighed 180 pounds, he lost 2 pounds a month for 8 months. So this model is going to fit only for 8 months, but again, your uncle's weight would be equal to, so the initial value is 180, and then since he lost 2 pounds per month, we're going to subtract 2 times the number of months. I'll use M for the number of months. And that would be the relationship. So at least in those 8 months, you could figure out how much he weighed. Obviously, it'd be easy to just keep subtracting 2, but there's the linear relationship. So again, that constant rate of change becomes the slope. So here's another one. You're designing a calendar as a fundraising project for your bio club. The cost of printing is $500 plus $2.50 per calendar. Write an equation to model the total cost of printing X calendars. So, if we want to just do the cost, if you notice on the vertical axis there's a C and a T at the top, that's because they're going to ask us to graph 2 different things. So we'll start with the C, the cost, and we know that the initial cost of printing is $500. So before you do any calendars, you have to pay that $500, so there's our y-intercept. And then you have to pay $2.50 for every calendar. Now, $2.50 compared to the block of $500, I really can't plot. So what I'm going to do is I'm going to go out to, let's say, 100. So if I print 100 calendars, 100 times $2.50 is 250. So that's going to take me another 250 up, which is about midway in that block. If I print 200 calendars, 200 times 250 is another $500. So that's going to put me there, and I can just represent that using that red arrow in this case. 35 says you sell each calendar for $5. Write an equation to model the total income T. Oh, sorry, I forgot to write the equation on the last one. So the equation for cost would be, we have to pay that initial $500, so there's your y-intercept, plus we have to pay $2.50 for every calendar, and they called it X, so we'll call it X, calendars. So then total income, which they called 2 in number 35 there, total income would be that we're going to bring in $5 for every calendar that we sell. So this is not profit, this is just the income, the total income that you bring in. So at 0, if you haven't sold any calendars, obviously you're not going to have any money coming in. But then if we plug in 100 for X, if we sell 100 calendars, we would get $500. So we could plot that. We sell 200, we get 1,000. Notice, same point. If we sell 300, we get 1,500. So what happens is this, there's our income in blue. So 36 says graph both equations in the same coordinate plane, which I just did. Estimate the point at which the two lines intersect. Well, we actually found that. My graph doesn't look perfect there, but we found that at 200 calendars we had exactly the same amount of money, $1,000. So the significance of that point of intersection, of course, is that's the break-even point. So if you sell more than 200 calendars, you're going to bring in money. If you sell less than that, you're not going to make a profit. So the last question there, if the club can sell 200 calendars, how effective is this fundraiser? Of course, it isn't effective at all. Hopefully they had a good time because they didn't make any money. So in the next section, we're going to write linear equations where we don't know the y-intercept, but maybe we just know a slope and point. So for example, write the equation of a line that passes through the point 6, -3, and has a slope of -2. So we're going to use the slope-intercept form, y = mx plus b. And we know the slope of -2, but unfortunately the point that's given is not the y-intercept. If it were the y-intercept, x would have to be 0. But it does give us an x value of 6 and a y value of -3, which means if we substitute those in, the only variable is b. So we can solve. So we have -3 is equal to -12 plus b. If we add 12 to both sides, 12 plus -3 is 9. There's our y-intercept. So the equation of this particular line then is y = -2x plus 9. So notice when you write the equation of the line, you have to put the x and y back as variables. Only the slope and the y-intercept should be constants, but that's the equation of the line. You can check it by graphing. So I plotted the y-intercept of 9. Again, our slope is -2. So these blocks on that vertical axis are 2. So you can go down 2 and right 2 would be equivalent to 1, or down a half and right a half. So notice that the point 6, -3 does fit on that graph with a slope of -2. So you can check all that. So to write an equation of a line given the slope and a point, you can find the y-intercept by simply substituting the slope and the point you have for x and y into the slope-intercept form and find the y-intercept. Then rewrite the equation of the line. So let's say we have two non-vertical lines that are parallel. They have to have the same slope, and we saw that in the last chapter. So write an equation of the line parallel to the line y = 2/3 x minus 2, but passes through a totally different point, -2, 1. So if you can check -2, if you plug in -2 into this equation, y is equal to 2/3 times -2 minus 2, you certainly don't get 1 out of that. -4/3 minus 2. You get -3 1/3. So we want a different line. But if it's parallel to that line given, that we know even on our parallel line the slope has to still be 2/3. So again, into y = mx plus b. We're going to substitute the 2/3 because it's parallel to the given line. Now we're going to put in that -2 for x, 1 for y, and we're going to solve for the y-intercept of this line. So we get 1 is equal to -4/3 plus b. -4/3 is -1 1/3. So if we add 1 1/3 to both sides, we get b is equal to 2 1/3 or 7/3. So the equation, the new line, is y is equal to 2/3 x plus 7/3 or 2 1/3. You can write that either way. So in this situation, the cost of a taxi ride has an initial fee of $1.50 for each mile, and your fare for 9 miles is $15.50. Write an equation that models the total cost y of the taxi ride in terms of the number of miles x. So again, we have sort of the same situation. We have a constant rate of change because you're going to pay $1.50 for every mile, but we don't know what the starting price is. So they asked us to use y and x. I probably would have used cost and m for miles, but so we'll use theirs. Y is equal to mx plus b is what we're going to use for slope-intercept form. And this time, we know, since the $1.50 per mile is the increase, that's our slope, and we know one point, we know one fare. We know for 9 miles, the total cost was $15.50. So all we have to do now is solve for b. So 9 times $1.50, 45, 4, you can check my arithmetic. So we get $15.50 is equal to $13.50 plus b. It'd be pretty embarrassing if I made a mistake on the video, wouldn't it? Oh, not two. Alright, so if we subtract $13.50 from both sides, we get $2 for the initial value. So the formula the taxi cab is cranking out there is that the cost, y, is equal to an initial $2 plus $1.50 for every mile. Call each additional mile x. So what's the initial fee? $2. Then we're going to have maybe not even the slope, but we're going to have the information of maybe 2 values in a linear function, or 2 points on the line, but we want to find the equation of the line. So again, what we always need for the equation of the line is we need the slope and the y-intercept, because that slope-intercept form is a nice, easy way to write the equation of the line. So given 2 points, we'll just want to find the slope first. And the slope is easily found by doing y minus y. Again, it doesn't matter, remember, which point I start with. I happen to start with the first one there, but now it matters that I start with the first x also. So over 5 minus 4. So I get a slope of 6/1. So now into y equal mx plus b, just like we did in the previous couple problems. We're going to substitute a slope of 6, and we need to plug in an x and a y. Now, this time I know 2 of them. It doesn't matter at all which one I plug in. So I'm just going to take the first one there. X is 5. And when x is 5, we know y is 3 because that's a point on the line. So we get 30 plus b is equal to 3. So if we subtract 30 from both sides, we get b is equal to negative 27. So the equation of this particular line is y is equal to 6x minus 27. And you could find any other point on the line because of that formula. Substituting a particular x, you could graph it. We're going to move on. Write the equation of the line through negative 1, 1 and 4, 5. So again, the key thing we need in the equation of the line is that constant rate of change, the slope. So we're going to find the slope by, again, doing, this time I'll start with the second point. 5 minus 1 over 4 minus a negative 1. So we get 4/5 for the slope. So into y equals mx plus b. I'm going to substitute 4/5 for m. Now I like that negative 1, 1. That's a little bit easier to multiply by 1, so I'm going to use that one. Again, we substitute one of the 2 points. It doesn't matter which one you choose. And we get 1 is equal to negative 4/5 plus b. So we're going to add 4/5 to both sides, and we get that the y-intercept is 1 4/5, or 9/5. So the equation of this particular line is y is equal to 4/5 x plus 9/5. Now if I wanted to graph that, I'd use the mixed form, the 1 4/5. I'd go up 1 4/5 of block. But a lot of times when they write the equation of the line, because the slope's a fraction, they'll write the y-intercept as a fraction. But you can write that either way. So now write the equation of the line through -6, -2, and 0, 5. This time, look at those points. Do you notice anything? One of the points has an x value of 0. So that means it's the y-intercept. So I'm thinking, yeah, wahoo, I don't have to find the y-intercept. So I'm just going to find the slope here. Y minus y over x minus x. I get a -7 over a -6, which is a 7/6 slope. And this time I can just write the equation because all I need is the slope. So 7/6x plus the y-intercept, which this time was nicely given. So write the equation of the line perpendicular to this particular line containing 8, -1. So you'll get different pieces of information and you just have to stop and think, how do I use this to write the equation of the line? Since what we need for the equation of the line is the slope and the y-intercept, you want to look at this initial line and you want to say, okay, what's the slope for that one? Well, the slope of this line is 3. So the slope of the perpendicular line should be, remember, the opposite reciprocal. So -1/3. So now I'm back to my data where we have the point 8, -1, and I'm going to write a different line now, because 8, -1, you can check it in your first equation. 3 times 8 is 24, minus 4 is 20. Certainly that point is not on that initial line, but we want the line perpendicular to that initial one. So again, we're going to start with the y equal mx plus b. We're going to plug in a -1/3 for the slope, an 8 for x, and a -1 for y. I'm going to solve for b. So we get -1 equals -8/3 plus b. So this time we want to add 8/3 to both sides. So I'm just going to put plus 8/3 over here. I'm going to add these two together. So if we add 8/3, remember that's -1 is a -3/3. So basically we get b is 5/3. So the equation of the perpendicular line is y is equal to -1/3 x plus 5/3. Okay, so our process is always try to look at the information given, figure out if you know the slope, figure out if you know the y-intercept, and if you don't, you just find them both. So in summary, step 1, when you're writing an equation of a line given 2 points, your first step is to find the slope using our y minus y over x minus x. Second, substitute the slope in one of the ordered pairs in for x and y and solve for b, unless of course you had any one of your points was 0, a number, then you know you have the y-intercept already. And then write the equation of the line, putting the slope back in as the coefficient of x and the y-intercept as the constant. Remember, every equation of line you need the x and y as variables. So our last problem here, geometry, we're looking at that quadrilateral on the graph, and it says 2 different non-vertical lines are perpendicular if and only if their slopes are negative reciprocals of each other, which we know. So it says A, show that segment AB and segment BC are perpendicular sides of the figure. First, well, if we look at the figure again, because those are integral values, we can just count blocks. So if we look at segment AB and we simply count from A down to B, we're going to go down 1, 2, 3, 4 blocks and write 2. So we see that -4 over +2 is a -2 slope, whereas from B to C, we're going to go up 3. I don't want to put another segment on there, it might look confusing, but up 3 blocks and right 6 blocks. You can count those over to 2, 0. So up 3, right 6 is a positive 1/2 slope. So yes, they are perpendicular because segment AB had a -2 slope and segment BC had a positive 1/2 slope. So there's our opposite reciprocals. So part B says write the equations for the lines containing those two segments. So again, those segments would extend into a line. And that's what we're trying to write the equation of, that line. So you see it here written out already. So the M, the green, for segment AB is -2. And then we'll just pick one of those 2 points. So in here in red, you see the -4, -3 was chosen. So that's a positive 8 plus b. So you subtract 8 and get -11 for the y-intercept. So that line is y equal -2x minus 11. And for BC, we'll do the same thing. The slope is 1/2. We can use that same point since it's in both of them. X is -4, y is -3. 1/2 of -4 is -2. So you can add 2 to both sides and you get b is -1. And the equation of that line is y equal 1/2 x minus 1. So we've worked a few times here with finding equations of lines, given a point and a slope, given 2 points, using graphs, using pieces of information. So those are the types of problems you're going to work on tomorrow in class. So go back and review any of these slides, and hopefully you took some good notes on them, and I'll watch your work tomorrow.